Okay, now let's talk about wind power. Now most of these slides are borrowed from a talk by David Osmond. So here are some wind turbines out in Australia somewhere. Now how does wind power normally work? Well, here's what a typical wind turbine looks like in the middle. You've got the rotor blades rotating around, and they're connected to a drive shaft and a gearbox, which then feeds through to a generator, which turns the rotation into electricity. Now, a minority of turbines are direct drive. They don't have the gearbox, they just go straight all the way through, but most of them have this. And the whole thing has a yaw bearing, which means it can swivel around to point towards the wind. And the rotor blades also have a pitch bearing, which means you can change the angle of the rotor blades to allow them to best extract energy from the wind. Or you can turn it flat on so they don't turn at all. How big are they today? Well, very big. Very, very big indeed. This is a typical size of wind turbines, and you can see that as time goes on they're just getting bigger and bigger and bigger. Typical one today is going to be 150 meters tall and generating many kilowatts of power. This is an example of how big they are. This is one of the blades for a wind turbine being delivered. And you can see the logistics of actually getting the blades to the wind turbines are very hard. You need wide roads and big corners. This is a very strange vehicle with a front here and the back there. These are enormous. Here is a wind farm close to Canberra, the Woodlawn Wind Farm, which is at Lake George. If you've driven to and from Sydney, you will have seen it on the other side of Lake George. This is an example of a typical modern on-land wind farm. It's got 23 turbines, each rated as a power of 2.1 megawatts, giving 48.3 megawatts in total. The hub, the middle, is about 80 meters high. Rotor diameter is 88 meters, so that means the tip is 124 meters above the ground. And here's what it looks like a bit closer along. These are some cyclists and runners nearby to give a sense of scale of how big these things are. And this is by no means particularly big by modern standards. Here is a typical week of generation from the Woodlawn Wind Farm. So here's its top rated power, which is 48 megawatts, and it never actually achieved that. But you can see that on Wednesday it was quite windy and it was sitting at about 45. I don't know why there's the gap here. I suspect maybe one of the turbines or two of the turbines was out of action for repairs or something at the time. But down here on Tuesday morning there was very little wind, they weren't generating very much, and then it jumps around in between with some windy times and some not so windy times. So the average power is a bit over 16 megawatts. What this means is it gives you a capacity factor. Divide 16 by 48.3 and that will tell you the capacity factor of this particular wind farm. Over a year, each turbine will produce the annual requirements for about 1,000 houses, so that's actually pretty good. There's a lot of power of these coming from these things. Woodlawn is a few years old now, so a modern wind turbine, if you were building one now, would be a bit taller, 150 meters to the top of the tower, 230 meters all up, 160 meters in diameter, and it'll put out about 5 megawatts maximum. Average power is less, 1.5 to 2.5 megawatts, so that's typically a 30 to 50% capacity factor. That's enough to power between 1,800 and 3,000 typical homes, but at times more and at times less, even zero. It takes a lot of materials to build one of these things. A single 3 megawatt wind turbine needs 355 tons of steel, 1,200 tons of concrete, 2 tons of rare earth elements. These rare earth elements are used in the generator to make the powerful permanent magnets to turn motion into electricity. 4.7 tons of copper for all the wiring and 3 tons of aluminium. Now in 2021, 94,000 megawatts of wind turbines were deployed around the world. That's around 30,000 new wind turbines. That's what we're deploying at the moment per year. If we're going to decarbonise the world, we're going to need to deploy a lot more than these in the future. And that means wind turbines alone required 11 million tons of steel, 36 million tons of concrete, 60,000 tons of rare earth elements, 140,000 tons of copper, and 90,000 tons of aluminium. So there's going to be a lot of mining and a lot of smelting to supply these wind turbines.